Piecewise functions. So what is a piecewise function? A piecewise function is made up of more than just one equation. So for our definition up here, what we would say, filling this in, is that it does not have one single equation. It has two or more. And each equation is used for some interval. Where no x values are the same. So what does this mean? So like for example, on this particular example right here, that means like you would just graph 2x plus 1 for only the x values that are just less than 1. You would only plug in 1. So you would do 2 times 1 minus 1. You would do 0, because 0 is less than 1. You would do 2 times 0 minus 1. You would do negative 1, 2 times negative 1 minus 1. You would do negative 2, and so on. So you would only do values that are less than 1. Then, for this one, you would do values greater than 1. Now, you would not use 1 itself. You have to go greater than 1. You could do 1.5 if you wanted to. But most of the time we start, we'll start at 2. Now, the tricky part is, what some students get confused with, we actually do start with 1. But even though it says it's not equal to 1, we would graph 1. And that is where we put a hole on the graph. So we got to have some starting point there. So we would graph 1. We break the rule just a little bit. But we would start with 1. We put a hole there. We don't fill it in. And then we would do 1. We would do 2, 3, 4. So we'd do like 3 times 1 plus 1. We do 3 times 2 plus 1. We do 3 times 3 plus 1, and so on. But we actually do start with 1. We break the rule a little bit. And then we put a hole there. Okay. So for our first example here, evaluate the following function, f of x. We do x plus 2 if x is greater than 2. So if the number is, less than 2. So if it's less than 2, you plug the number in to this function. If the number is 2 or bigger, we plug the number in to this function. Okay, so for the first one, we do f of 0. So since 0 is less than 2, we're going to plug it into the top one because 0 is less than 2. So we will do 0 plus 2, which is 2. So we would say f of 0 equals 2. All right, so for B, it is 2. Well, for that one, it meets this requirement because 2 is equal to 2. So we do 2 times 2 plus 1. So that's 4 plus 1, which is 5. So f of 2 equals 5. Then we do f of 4. Well, f of 4 also falls into the second one because it's greater than 2. 4 is greater than 2. Okay, it meets that rule. So we do 2 times 4 plus 1. 2 times 4 is 8. 8 plus 1 is 9. So f of 4 equals 9. So you just see which one of these you're looking here on the ends to see is x. Is it less than 2? Is it equal to 2? Or is it bigger than 2? Okay. So now what we're going to do is we're going to graph the function. We'll state the domain and range in interval notation. And we'll state any locations where the graph is discontinuous. And we will use a table of values to help us. And then we'll use Desmos in the end to kind of verify and help us out. So the first thing I like to do is I like to look at these values here. And I establish what I call a fence on my graph. So I go to 1, and I call this my fence. And it sounds a little cheesy, But I think of my graph as property. I think of this as a property line. This is my fence that splits up my two property lines. And I think of my two equations as like my two people that owns each side of my property line. So 1/2 x plus 2 owns everything on this side, less than 1, okay? So the 1/2 x plus 2 owns everything on this side because it's less than 1, so it owns everything to the left. And then the negative x plus 3, because it says it's greater than 1, owns everything on the right side, okay? Because think of this, we are, if you think of it, this right here, this is a number line. I mean, think of it like that. Okay. All right. So, if I first do my fence for 1/2 x plus 2, if I do my x values, I'm going to start with 1, okay? So it said, we talked about that, I talked about that just a few minutes ago, but it can't equal 1. Looking at this sign, it can't equal 1. So that means I'm going to put a hole there, okay? I'm still going to plug in 1. I'm going to do 1/2 times 1 plus 2. 1/2 times 1 is 1/2, and 1/2 plus 2 is 2.5. And I am going to just put a decimal here. So that means my coordinate is 1, 2.5, and that is my hole. So I plot 1, 2.5, and that is a hole. Okay? All right. Now, I have to follow my rule. X is less than 1, so I have to continue with values that are less than 1. So I would do like a 0 and a -1. And I could keep going because it's less than 1. So as long as I would keep doing numbers less than 1, I'm good. But I want to just do a few numbers to establish where this line is going. So if I do 0, 1/2 times 0 is 0. 0 plus 2 is 2. So my point is 0, 2. And that's just a point. After we do that first point, or after we plug in that first value, the rest of them are going to be points. Then we do 1/2 times -1. So that's going to be a -1/2. -1/2 plus 2 is going to be 1.5. So I can see the pattern here, and I'm going to know it's going to continue to go this way. Okay, so now I'm going to do my other line. So my other line is the -x plus 3. I'll do my x, and I'll do my y. So once again, I'm going to start at 1 here. So if I plug in 1, so here's the negative. It's already in the equation. Plug in 1. -1 plus 3 is going to be 2. So my point is at 1, 2, just below here. And I know it can equal it, so that's going to be a point. So let me skip down a little bit lower here. So now these values are going to be greater than 1. So anything greater than 1, so I'm going to go to 2. So negative is in my equation, so -2 plus 3, that's going to give me 1. Let's do one more, so let's do 3. So that's -3 plus 3 is going to be 0. So I can see the pattern that this one is establishing. Okay, so here's what my graph looks like. Now, if I want to check to make sure that I did graph it right, I can check on Desmos. Okay, so I've already got my equations entered. So if you want to, and I've got a lot of graphs on here, and you just turn them on and off by clicking this part right here. So that just turns them on and off. And I've got the other ones from our notes plotted in here just to save us a little bit of time. But my first two up here are the first two that we're looking at. So if you notice my lines are correct, notice your restrictions, like the x minus 1, notice I've put those in curly brackets. So if you want to do that, that's how you're able to get those in. You don't have to do a space or anything like that, just brackets. Now, to know that it's a hole, notice there's no hole that shows up on Desmos, okay? That's something that you have to know. But here's a little trick. if you click on the very end, if you go to the very end and click, it will show that hole, but you have to click on it. And it shows the hole up there, and it does say undefined, okay? And if I were to click on this one and go to the very end, it doesn't show a hole. It shows that point at 1, 2. And notice if I were to zoom out, it shows that those lines keep going forever and ever and ever, okay? All right. So let's do domain and range. So remember, domain is how far left, how far right it goes, okay? So my domain, it is going, so we're seeing, we're looking right here. It's going to the left forever. So that's negative infinity, okay? And if I am going to the right forever, I'm just seeing how far to the right it's going. Basically, it is going to the right forever, okay? Even though there is a gap, even though I see this little gap right here, I have a point right here, okay? So I can look at this graph and say that my domain, I have a value at every x, okay? So my domain, I have a point at every x, okay? So my domain goes from negative infinity to infinity. So for my range, I see how low it goes. So remember, it's the lowest to the highest. So for my range, then I would go from negative infinity, and I'm going to see how high it goes, which is going to be right here. Okay, so this is the highest point because this line right here is continuous up until this point right here. And you're looking at the y value, and that y value right there is 2.5. Okay, so we would fill that in, and that's going to be 2.5. And it gets a parenthesis since it's a hole. Any solid point is going to get a bracket. Any hole would get a parenthesis. So that's going to be your range. Okay, so now we're going to do discontinuous. Any points, any holes are going to be points of discontinuity. So we would say that it's discontinuous at x equals 1. And we say that it's discontinuous because of that hole being there. Because if you think about it, if you were to kind of like lay your pencil vertically on this graph and kind of slide it across, you run into a hole. Or that's kind of the way I think of it. So you have holes on your graph. The whole graph is not continuous, in other words. Anytime you have holes, it's not continuous, okay? And you always say the x value. You use the x value to say that it's not continuous. So wherever the x is, the x was at 1 at that place, that's where it's discontinuous. Okay. So then for our next one, okay, so we look at our numbers to establish like our fences, okay, what I like to call my fences. So you've got a -3, a 1, the 1 is there twice, and then you've got a 4, okay? So we've got -3. So I'm going to fence here, a 1. So 1, 2, 3, and then a 4. So these are where my fences are going to be. And I like to just put my boundary lines there. So negative x plus 1 is between -3 and 1. So negative x plus 1, that graph is going to be between those lines. And x minus 1 is going to be between 1 and 4. So that graph can only be between those dotted lines. So if you think about it, basically, there's no graph that's going to be over here. No graph, no lines can be in this section over here, okay? Nothing can go past those dotted lines on either side, okay? All right, so if we establish our tables, I've got negative x plus 1. I got my, let me slide over just a little bit. I've got my x and y values. Okay, so I'm going to start at negative 3, okay, because this is where it starts. Now, since this is my inequality, that means that this first one here is going to be a whole. It can only be filled in if it's equal to, okay? So I've got a negative, and then negative 3 is when I'm plugging it in. Negative is from the problem here. So that's going to turn into a positive 3. Positive 3 plus 1 is 4. So my first point is going to be negative 3, or sorry, yeah, negative 3, positive 4. And it's a whole. Okay? Now, since this one is between 2 points, most of the time what I do is I'll do a point in between. I'll do the beginning point, I'll do the end point, and I'll do a point in between. So a point in between, let's just do 0. So then I have negative 0 plus 1. 0 is not negative. 0 plus 1 is going to be 1. So I have 0, 1. Okay? Because anything in between, I always fill it in, and we don't have to worry about it being a whole. And then I'm going to plug in 1. So negative from the problem, 1 I plug in, and then that's going to be 0. Now, being that this is equal to right here, I do fill it in. So we get 1, 0. And this is just going to be a straight line, so I can connect these points. Okay, so now I do my second one. So I have x minus 1. Okay, so if I start with the 1, and remember, since this is my sign, that means that this one is going to be a whole. I'll go over here so I got a little more room. So I've got 1 minus 1, which is going to be 0. So my point is going to be 1, 0. Now, I already have a point here, so that's just the same point, okay? So a point overrides a whole. So I don't have to worry about putting a whole or erasing it or anything like that. A point always overrides a whole. So let's do something in between 1 and 4. Let's just do 2. I could pick anything I wanted. So if I plug in 2 minus 1, I'll get 1. So let's plot the point 2, 1. And we'll do 4. We'll do the end point. What's on the very end. So 4 minus 1 gives me 3. So 4, 1, 2, 3. And that one I fill in because this sign has the equal to in it. And that line goes straight up. Now, if I want to verify what this looks like on Desmos, okay, I'm going to get rid of these first 2 here. These are 2 from this problem. If I scroll in here, okay, remember if I want to click on this, that right there shows me that that one was a whole, okay? If I click here, you know, there's my 0.10. That is a point. And if I click on, go all the way to the end, that right there is definitely a point. Okay. Okay, so now let's talk about domain and range. How far left and how far right it goes. So domain, the furthest left it goes. So the furthest left it goes is right here. Okay. And that x value is -3, and it's a whole, so it gets a parentheses. Wholes always get parentheses, points get brackets, okay? Now, the furthest right it goes, this is the furthest right it goes. So the furthest right it goes is 4, and it gets a bracket. All right, so let's do my range. The lowest it goes is right here. This point right here is the lowest. And I do my y value right here, because range, we talk about y values. That y value is a 0, and it gets a bracket since it's a point. All right, this is my highest point. I look at my highest point, and I look at the y value at that highest point. And the y value at the highest, at that right there, is at, because it's right there at, I'm looking at the 4. Okay, now, since it is a whole, it does get a parentheses, okay? And it is discontinuous at x equals -3, because that's where my whole is. Okay, if we look at this one, okay, so remember, absolute value ones are going to look like a V, Okay, keep that in mind. So you should see a V shape. We may not see the entire V shape depending on what part of the graph I get to actually do because of this right here. Okay, now what I'm going to do, remember I'm going to do my little fences. I'm going to do my little boundary lines. My little boundary lines are going to be -2 and just +2. Okay, so I've got -2 and I've got +2. Okay, so absolute value of x plus 3 is going to be on the left side of -2. Okay. Then x squared plus 1 is going to be between -2 and 2. And then I have 3 where it's x is greater than 2. Okay, so the first one I'm going to do, absolute value of x plus 3. I'll do my x and I'll do my y here. All right, so I'll start with -2, -2 plus 3. So that's going to give me 1. Absolute value of 1 is just 1. And I do get to fill that in because it's equal to. So -2, +1. All right, then I'm going to do is something less than -2, so -3. All right, that gives me 0. All right, so -3, 0. Let's do one more. We could keep going because this is less than -2, so I could keep going forever and ever and ever. -4, -4 plus 3. Now, -4 plus 3 is -1, but the absolute value of -1 is +1. So be careful there. Make sure you do that correctly. So -4, +1, it starts to give us that V shape. So I know I would be going back up. So there's that part of the absolute value graph. Okay, so now if we do x squared plus 1. All right, so if I start with -2, and remember this one is going to be a whole because of the sign here. It's just strictly x is greater than. So if I have -2 squared plus 1, that's going to be 4. 4 plus 1 is 5. So -2, 5. That's going to be a whole. And remember, an x squared is a parabola. Okay, so this is going to have that curve to it. It's going to have that U shape. Okay, let's do something in between. Let's do a 0. So 0 squared plus 1 is just going to be 1. So 0, 1. And let's do our 2. So 2 squared plus 1. So 2 squared is 4, 4 plus 1 is 5. So then I have 2, 5. And that one is filled in. That one is solid. So remember, this one was a whole because of the sign, but that last one's filled in. So this one is a parabola because x squareds are quadratics. Those are parabolas. Okay, so 3, remember, that's just a line. Like if it was just y equals 3, that would be like y equals 3. Okay, remember that is a horizontal line. Okay, but it's only for x is greater than 2. Okay, so if we go up to 3, 1, 2, 3, we start here and we only graph it from there over. Okay, because it's only where x is greater than 2. All right, and it's the whole is there because of that sign. Now, if we want to look at our graph, if we want to check it on Desmos, get rid of those two. And we want to look at it there. We see our parabola. If we want to check for holes, that one's not a hole. That one's filled in. If I want to zoom out a little bit, I can see that V shape would go forever and ever. Okay. I see that part of my parabola. There was a hole. It's undefined. Here gives me the point all the way up. If I can get up there. Yeah, there we go. And here, there's my hole right. I can see if I zoom out, that line is just going to the right forever. Okay? Okay, so if we do our domain, I can see that it's going to the left forever, so negative infinity. Infinities, negative or positive, they always get parentheses. Okay? Now, as I move from the left to the right, I do have a value here at -2, okay? So since I have a value of -2, I don't have to stop at -2. I can keep going. As I move across my graph, I see that I have a hole at +2, but there is a value at 2, so I can keep going. And it does go to the right forever. For my range, my lowest point is 0. This is my lowest point right here. That's my lowest, and it's a point. So it gets a bracket. And I can see, like right here, if I kind of focus on this part right here, it's going up forever. And since it's going up forever, it gets an infinity. Now, parts of discontinuity, I would say that this one is discontinuous at x equals, so you look at where your holes are, holes that haven't been filled in, discontinuous at x equals -2 and x equals +2. Okay, last one we'll look at here. If we fill in, let's look at our fences first. We've got the -3 and we've got 1. We've only got 2 fences on this one. So -3. And we've got +1. Okay. So -2x plus 1 is between -3 and 1. 2 is actually just on that line. And then the x squared is to the right of 1. Okay. So if we start with -2x plus 1. Okay, so I'll start with -3 because that's like my starting number there. So -2 times -3 is 6. 6 plus 1 is 7. And that is a point that's filled in. Okay. Then we'll do something in between. Let's do a 0. So -2 times 0 plus 1, that's just going to give me 1. And let's do my endpoint, 1, -2 times 1 plus 1. So -2 plus 1 is going to be -1. And that one is a hole because of the sign right there. It's not an equal to. Now, this is just a straight line. That one's linear. Okay? Okay, so the y value is 2 if x equals 1. So that just basically means that is a coordinate, 1, 2. That's just a point. That's all that is. That is just a coordinate for that second one. Okay? Then if we do x squared, okay? So we're going to start at 1. So 1 squared is 1. And remember, this one is a whole because it's not equal to there. So we've got 1, 1. We'll do 2. 2 squared is 4. So we've got 2, 4. And remember, this is going to be parabola. So we're going to get pretty big pretty quick. If we did 3, we would get 9. We'd go off the graph. So this is a parabola. It's got that curve to it. And it's going to go up forever. Okay? If we want to check Desmos to see what this one's going to look like, we've got this one. Now, our point's not going to show up on Desmos for this one. But just know, like the way we got it typed in, but that's going to be our point. It's going to be 1, 2. So if I were to redo this one and just do it as a coordinate, then that would actually give me my point. Okay, that would look a little bit better. Okay, so if I wanted to check for points of discontinuity, so there's a point, okay? If I did this one, there's my hole. And then here on this one, there's my hole. And then I can see, if I zoom out, I can see that that red graph is going to go up forever. Okay? All right. So let's do domain and range and points of discontinuity. So my domain right here is the furthest left it goes. So the furthest left it goes is -3, and it's a point, so it gets a bracket. And it's going to go to the right forever. Now, if I look here, even though there's a hole here and there's a hole here, I do have a point at the value of 1 there. So that means that my domain, I do have an X value there. So I'm good to say that my domain, I do have an X value everywhere. Okay, from -3 to infinity, there's an X value that exists everywhere. Okay, so that's why I can say domain is from -3 to infinity. Then my range, this right here is my lowest point, is at -1. Since it's a hole, it gets a parentheses. And then this line is continuous. It covers all the Y values from here to here. So it covers, this fact that I've got a hole right here. And then, this line goes up forever. So since it's going up forever, I've got infinity. And then it is discontinuous at x equals 1.